Hello students, in this video we learn about Newton-Raphson method. It is an iterative method used to find root of the equation f of x equal to 0. The Newton-Raphson method is given by the formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n is equal to 0, 1, 2, etc. So we get first iteration by substituting n as equal to 0. Then the formula becomes x1 is equal to x0 minus f of x0 divided by f dash of x0. The second iteration is obtained by substituting n equal to 1 here. So we get x2 as equal to x1 minus f of x1 divided by f dash of x1. Similarly, the third iteration is obtained by substituting n equal to 2 here. So the formula becomes x3 equal to x2 minus f of x2 divided by f dash of x2. Fourth iteration, for n equal to 3 we get fourth iteration. The formula is x4 equal to x3 minus f of x3 divided by f dash of x3 and so on. Now the very important note, you need to remember this note. If x0 is not given, then choose A and B with the condition A is always less than B, such that f of A into f of B is less than 0. That is, f of A and f of B are of opposite signs. And we have to choose x0 as whichever value of f of A or f of B tends to 0 faster. Suppose f of A tends to 0 faster, then we will take A x0 as A. Suppose f of B tends to 0 faster, then we take B as x0. Now we will work out some problems. First problem. Find a real root of the equation x cube plus x square plus 3x plus 4 is equal to 0 near x equal to minus 1. Correct to 4 decimal places using Newton-Raphson method. Now we first write the datas given. Given equation is f of x, that is x cube plus x square plus 3x plus 4. And this x equal to minus 1 is nothing but x0. x0 is minus 1. F dash of x, 3x square plus 2x plus 3. Now we write the formula. The Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 1, 2, etc. First we obtain first iteration. To obtain first iteration we substitute n as 0. We substitute n as 0 here. So what we get is x1 is equal to x0 minus f of x0 divided by f dash of x0. So it is equal to x0. We write f of x0. We know what is f of x. F of x is x cube plus x square plus 3x plus 4. So f of x0 is x0 cube plus x0 square plus 3x0 plus 4. F dash of x0, that is derivative of f of x, is f dash of x, which is 3x square plus 2x plus 3. So f dash of x0 is 3x0 square plus 2x0 plus 3. And we know that x0 is 1 minus 1. x0 is minus 1. So when you substitute x0 as minus 1 in this equation, we get x1 as minus 1.25. Now we obtain the second iteration. For n equal to 1, formula becomes x2 equal to x1 minus f of x1 divided by f dash of x1 which is equal to x1 minus x1 cube plus x1 square plus 3x1 plus 4 whole divided by 3x1 square plus 2x1 plus 3, and we know that from the previous step x1 value is minus 1.25. So when you substitute these values here in this equation, we get x2 as minus 1.22289. Now we obtain third iteration. For n equal to 2, the formula is x3 equal to x2 minus f of x2 divided by f dash of x2. That is x2 minus x2 cube plus x2 square plus 3x2 plus 4 divided by 3x2 square plus 2x2 plus 3, and we know that x2 is minus 1.22289. When you substitute these values in this equation, we get x3 as minus 1.22249. We have to get the answer correct to four decimal places. So fourth iteration is given by, for n equal to 3, x4 equal to x3 minus f of x3 divided by f dash of x3. So it is x3 minus x3 cube plus x3 square plus 3x3 plus 4 whole divided by 3x3 square plus 2x cube 2x3 plus 3, and we know that x3 is minus 1.22249. When you substitute here in this equation, we get x4 as minus 1.22249. So the required root correct to four decimal places is x equal to minus 1.22249. Now the second problem, find the real root of the equation x sin x plus cos x is equal to 0 near x is equal to pi, correct to four decimal places using Newton-Raphson method. So the solution, given equation we take it as f of x, that is x sin x plus cos x. X naught is given as pi, given x is nothing but x naught. F dash of x, so here we apply product formula for differentiation. First function is x, derivative of sin x is cos x, plus second function sin x, derivative of x is 1, minus or plus derivative of cos x is minus sin x. So plus sin x minus sin x cancels. The remaining part is x cos x. So f dash of x is x cos x. The Newton-Raphson method is given by the formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, 3, etc. Now the first iteration, for n equal to 0, the formula is x1 equal to x naught minus f of x naught divided by f dash of x naught, which is equal to x naught minus f of x naught is x naught sin x naught plus cos x naught divided by x naught cos x naught. Here x naught is pi. Students, also we have to remember one more thing. The given equation contains a trigonometric function, so we have to use calculator in radian mode. So when you substitute x naught as pi in this equation, we get x1 as 2.82328. Now the second iteration, for n equal to 1, the formula is x2 equal to x1 minus f of x1 divided by f dash of x1, that is x1 minus x1 sin x1 plus cos x1 divided by x1 cos x1, and we know that from the previous step x1 is equal to 2.82328. When you substitute here in this equation, we get x2 as 2.79860. Now the third iteration, for n equal to 2, x3 is x2 minus f of x2 divided by f dash of x2. So it is x2 minus x2 sin x2 plus cos x2 divided by x2 cos x2. Now substitute for x2, which is 2.79860. So we get x3 as equal to 2.79839. We have to get the answer correct to 4 decimal places. So fourth iteration, for n equal to 3, the formula is x4 equal to x3 minus f of x3 divided by f dash of x3, that is x3 minus f of x3 is x3 sin x3 plus cos x3 divided by x3 cos x3, and we know that from the previous step x3 is 2.798390. So we get x4 as 2.79839. Therefore the required root is x is equal to 2.79839, correct to 4 decimal places. Now the next problem. Find by Newton-Raphson method the real root of the equation 3x equal to cos x plus 1, correct to 4 decimal places. So we write f of x as 3x minus cos x minus 1. F dash of x, derivative of 3x is 3, derivative of cos x is minus sin x, already one minus is here. So minus of minus becomes plus. F dash of x is 3 plus sin x. And most important thing, x naught is not given. So whenever x naught is not given, we have to follow the following procedure. So to find x naught, consider f of x is equal to 3x minus cos x minus 1, which is f of x. Now we start with trial and error method. So we start with f of 0. What we get is minus 2, which is less than 0. F of 1, which we get it as 1.4597, which is greater than 0. So one value is less than 0 and the other one is greater than 0. So f of 0 into f of 1 is less than 0. So there exists at least one real root in the interval 0 to 1. Now we have to choose x naught value. So we observe here f of 0 is minus 2, f of 1 is 1.45. So 1.4597 approaches 0 faster than this minus 2, right? So we take x naught as 1 because f of 1 approaches 0 faster than f of 0. So x naught is 1. The Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, 3, etc. Now the first iteration for n equal to 0, we know the formula x1 equal to x naught minus f of x naught divided by f dash of x naught, which is equal to x naught minus 3x naught minus cos x naught minus 1 divided by f dash of x naught becomes 3 plus sin x naught, and we know that x naught is 1. When you substitute x naught as 1 in this equation, we get x1 as 0.62002. Now the second iteration for n equal to 1, the formula becomes x2 equal to x1 minus f of x1 divided by f dash of x1, which is x1 minus of 3x1 minus cos x1 minus 1 divided by 3 plus sin x1, just replacing x naught by x1. So we know that x1 value is 0.62002. So we get x2 as 0.60712. Now the third iteration for n equal to 2, the formula is x3 equal to x2 minus f of x2 divided by f dash of x2, which is equal to x2 minus f of x2, which is 3x2 minus cos x2 minus 1 divided by 3 plus sin x2, and we know that x2 is 0.60712, so we get x3 as 0.6071. Therefore, the required root corrected to 3 decimal places is x equal to 0.6071. Now one more problem we will solve. Using Newton-Raphson method, find the root of the equation x e power x equal to 2 near to x equal to 1, correct to 3 decimal places. Here x naught is given, f of x is x e power x minus 2, x naught is 1, so f dash of x, so we have to use product formula. First function is x, derivative of e power x is e power x, plus second function is e power x, derivative of x is 1, derivative of 2 constant is 0. The Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn for n equal to 0, 1, 2, etc. Now the first iteration is obtained by substituting n as 0 here. So the formula is x1 equal to x naught minus f of x naught divided by f dash of x naught, which is x naught minus of x e power x naught minus 2 divided by x naught e power x naught plus e power x naught. It has to be e power x naught. Here x naught is 1, so we get x1 as 0.8679. Now the second iteration, for n equal to 1, we get x2 as x1 minus f of x1 divided by f dash of x1, which is x1 minus x1 e power x1 minus 2, x1 e power x1, it is not even x, x1 e power x1 plus e power x1. So when you substitute x1 as 0.8679, we get x2 as 0.8528. Now the third iteration, which is obtained by substituting n equal to 2 in the formula becomes x3 equal to x2 minus f of x2 divided by f dash of x2, which is equal to x2 minus x2 e power x2 minus 2 divided by x2 e power x2 plus e power x2. And we know that from previous step x2 is 0.8528. So when substitute this x2 value here in this equation, we get x3 as 0.8526. Thus the required root is corrected to 3 decimal places is 0.852. We continue the problems in our next video. Thank you.